Hello, good evening, dear students. Welcome to Agentic AI Developer with IBM session. Hope your day went really well. Good evening, all of you. Good evening, Prashant. That's the energy. Great. Good evening. So let's wait for a couple of minutes so that others join and then we'll begin. Okay? Good evening, Harshit. Good evening, Chinmay. Good evening, Gaurav. Good evening, Nikal. Good evening, Satyam. Good evening, Nishant. Good evening, Anmay Shukla. Good evening, Disha. I see new names today. Hi, guys. Good evening, Tanish. Good evening, Divyata. I meant in the chat, I see new names, meaning people, you guys, I only see a couple of people continuously texting, being active. Today, I'm seeing new names in the chat. Oh my God, Prashant Jadhav from KIT, big fan of me. Thank you. Big fan of you as audience. Okay, Divyata. Nice to see you again. Good evening, Kuldeep. So let's wait and then we'll begin. Thank you. Hello, guys. I hope a lot of them have joined in this meantime. Shall we begin? Can I get a quick thumbs up? Hi, hello, DY Patil, Mohit. Okay, let's do one thing. This thumbs up and all is very ordinary and boring. Now, all of you, give me that cheers emoji if you have the option to do it. Can you all give me a cheers so that we'll all begin? I need to see my screen covered with so many glasses. Cheers, cheers. Yes. Hmm. Good, 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 good. Coffee? Ha. Nice. चलो 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 चलते हैं शुरू करते हैं हमारे हाँ welcome to the session all of you. Sorry for my Hindi. So today we are going to get into understanding agents deeper. Okay, we'll learn a lot of things today. Okay, so I want you to be fully attentive. Okay, fully energetic with so many responses. My chat should be filled with so many responses, guys. I don't know. Okay, make sure you're typing really well. Okay, so what did we cover yesterday? A quick recap again. Hmm. Gym, guys. Yeah. Machine learning. We have covered a lot of things. I know we didn't get into deeper of ML, I understand, but I request you to do your self learning in machine learning so that you get good understanding. Yeah, machine learning steps. We learned how to cook biryani, Hyderabad biryani. Yeah, and we explored EDA, we explored Python, basic Python, and then the all the machine learning models and simple learning also. Right? So ML process also. Yeah, Divyata, correct. 6 steps. Okay, can you guys quickly type all the 6 steps that we have discussed about ML? It's not just for ML. The same thing will be continued for deep learning and generative AI also. So this is the base, right? So everybody must know those 6 steps. Can you all quickly type? I'll be waiting. Mm-hmm. Good. There is a certain format from each one of you. Somebody are typing one after the other, somebody without commas, somebody with commas, somebody with arrow marks. Nice. Data collection, data pre-processing, data modeling, data testing, data deployment, monitoring. Great. There are hundreds of students in the session, but only a couple of them are answering. Hello, others. Can you all be active in the chat? If not, maybe at least reactions. You have so many emojis, guys. Thank you. Chalo. So ML is done. Now, what is the next step? Okay, Harshit. Let's pray for the India and New Zealand match. taking time to settle. Hello, ठीक है. Hope you are settled now. So, okay, guys. So, what is the next thing after ML? We learned ML. Next, generative AI. If somebody is saying generative AI, between ML and generative AI, there is a bigger concept. What is it? Can anyone tell me? We have machine learning brother. Who is that? No, no. Machine learning's brother. Yeah, deep learning, correct. So let's understand. I'll quickly cover the concepts of deep learning. Okay. So before that, I'll also tell you what is today's agenda. So we will be discussing the after recapping the deep learning, we will quickly understand the different characteristics of AI agents. Okay, the components, the major components you all need to know in of AI agent. Okay, and differentiate between the different types of AI agents. Okay, we will also discuss real world use cases, and most importantly, we'll discuss about IBM's role in Agentic AI. Okay, shall we begin? Okay, can you all of you, let's begin. Rocket. Before rocking, I want you to quickly show me the emoji of the exploratory one, where the smiley emoji is holding a magnifying glass, so that I can know you're all very much interested to get into deep learning. Yes, that is it. Yeah, nice. Good. So what is deep learning? Deep learning. So this deep learning contains number of neurons. Okay, you don't need to be afraid of this term. Deep learning sounds complex, but the idea behind it is actually very human. Okay, think about how you learn to recognize people. Nobody gave you rules like, okay, if the nose is this much, if the eyes are this much, then only it is a human, or else no. No, you just saw the faces again and again. Okay, slowly without even realizing it, your brain learned patterns, right? So this is exactly what deep learning does. It learns from examples, not instructions, guys. Okay, yes, deep learning is machine learning with a deep multi-layer brain. Exactly, Prashant. Okay, deep learning works extremely well with structured data. What do you mean by structured data again here? Rows and columns. Structured data simply means information that follows some patterns like marks, attendance, bank transactions, purchase history, sensor reading. When AI sees enough of this data, it starts identifying relationships that humans also might miss. Okay, not because humans are not intelligent, but because humans get tired. Yes, we lose energies by end of the day. I hope you're all having that energy right now to continue the session, but AI does not. Okay, so when companies use deep learning for prediction or classification, they are essentially asking the AI to answer few questions like what is likely to happen or which category does this belong to. They're not asking the questions from the data. They're asking some predictive analysis questions. Okay, by this, the mission has to understand the data and then come up, tell the investors or the stakeholders the reasons behind why that is happening. Okay, the important thing for you to understand is deep learning is not some magic. It is pattern recognition at scale, massive scale. Okay, a human might analyze hundreds of examples, but AI analyzes not hundreds, not thousands, but millions. Okay, that difference in scale is what makes AI powerful. Okay, I get good answers. Correct. Um, yeah. Don't. So let's get into the types. Okay, quick one. So ANN, artificial neural networks. Okay. So these are neurons, deep neural networks. Okay. So it's a foundation, of course. Okay. It only works with structured data. In machine learning, yesterday we have seen the classification and regression tasks, right? So those things also can be done in ANN, but at a higher speed and higher accuracy. Do you understand? Have anyone in the meeting explored ANN and tried to build a model with ANN? No? Oh, yes. Okay. No problem. It's very easy. You just need to get in, take the data, just write few lines of code, and then it will be done. You just need to understand how it is working. Not, don't worry, it will be done. Okay. Chalo, this is about ANN. There are three things, ANN, and the second thing we have is CNN, Convolution Neural Network. Okay, so this is something related to images. ANN was about structured data. Okay, right? Now, coming to CNN, it is completely about visual data, pixels. Okay, how it works. So, when you look at a photo, you instantly understand, right, what it is because we are humans, we naturally identify things. Computer vision, yes. Behind that, yeah, behind that, the architecture is CNN. Yes. So if see, we identify a road, if maybe if a face, animal are friends, we instantly identify. But for a computer, an image is not a face. It is just numbers. Do you think a computer can understand anything just by looking? No, right? It only understands numbers, right? So each of the pixel in the visual data is converted into numbers and the machine is learning from the numbers. Do you understand? Thousands and millions of tiny dots. How many of you know pixels here? I hope everybody. Pixels. Those thousands of tiny dots. You all know, right? So those are the pixels. And each one of each pixel has some or other color. So based on that only we get the good images, high quality images, right? So each pixel is here used to identify the visual data. Okay. CNN exists to help AI make sense of all these pixels. Okay. They don't look at an image all at once. Okay, they don't look at this. Do you see the cat image here? They don't look at the entire thing at once. Okay, it look at smaller parts. Do you see the grid on one side of the cat? So each grid is separately identified, analyzed. Okay, layer by layer, it builds understanding. First, it learns lines, then shapes, then objects. Okay, then finally, it understands the meaning. This is very similar to how humans learn and draw. See, you guys didn't know walking. You guys didn't know how to hold a pen and start writing letters or alphabets by birth, right? So you started when you go to nursery or preschool. There they make sure kids draw little lines like small slanting lines, sleeping line, the circles, the dots, the shapes, and then they'll start writing the alphabet. They'll teach alphabets, right? It's not that they are going to directly get into alphabets. So similar way here also, the machine starts identifying the little details. How are the shapes? How are the edges? Okay. How are the lines? Everything. Okay. And how many of you are having this face lock, mobile phone face lock? Do you think it knows you personally? Hmm? आपका फोन आपको जानती है? No, of course. You're not connected emotionally to your phone, right? Just a second. Uh, yeah, I was on mute because I had to take a call. Okay. So I was talking about phone uses face recognition. Exactly. So it recognizes patterns in your face structure that also match some patterns which it is already trained on, right? Um, Guys, how many of you use Instagram here? Do you tag people sometimes? Or is it already automatically tagging people in posts? Do you know this? Automatically tagging people? Try this. Best example I would suggest is Google Photos. You go to Google Photos, at one point in one section, you find folders of grouping images of the same person across years. How it is identifying? Hmm? It's all because of CNN is working silently in the background. So the CNNs are also used in many places, guys. Medical imaging, where AIs can scan X-rays, MRIs to detect issues earlier than human. I don't know how many of you know this particular case, but let me tell you one interesting case. This was long back, like five to 6 years back. Not 5 to 6 years, 10 years back, I think. Uh, there was a lady with few symptoms of breast cancer. Okay, so doctors have scanned her and they told her that there is no symptom or no cell that is affected by cancer. Okay, they have given her reports to AI few years back. Okay, now the AI has detected that she will be diagnosed with breast cancer. There she will, yeah, she will be diagnosed with breast cancer. Doctors then rejected the AI, meaning they did not believe the AI because they thought we are the doctors, we know the reports are clearly saying that she will not have or she's not having the breast cancer. But the AI has detected 4 years back, I mean, 4 years after that situation, the lady was diagnosed with actual breast cancer in maybe, I think, the last few stages were left for her. Okay, that's how it happened. Meaning the AI actually detected the cells. Okay, in all her reports, it has detected couple of cells which were just beginning to start the cancer cells. Okay, then only she did not use ChatGPT, but yeah, the AI itself identified the cancer cells long back in her body in all her reports, but human doctors could not identify that. AI could identify that. This was long back. Imagine what AI could do now. This was long back only, it was identifying the little cells. Now, my God. So that's how in medical also it works. It is doing really great job in medical, to be honest. But medical meaning it's about risking life only, right? So they are doing a lot of developments and research in AI medical, AI in healthcare. They're very what do you strict, very responsible, very strict with all the data, with all the information, with all the outputs AI is generating. Also, they're very careful. Yes. Okay. So this is all about CNN. The key idea here is CNNs gave AI vision. Vision, yeah. So and once AI can see into a real world observer, and once AI can observe the world, what happens, guys? Can you tell me? What happens? Yeah, produces action. It starts acting. Correct. Okay. Anytime I also use T code, CT or MRI. Yeah, even I do that. I take the reports whenever there is any medical issue. I definitely go to AI and give all the reports. Produces action. What are spatial features? Okay, spatial features are nothing but the patterns. Like I have told you, right? It identifies the edges, corners, textures, and some complex parts of that particular. If it is a face image, the machine has to understand the difference between eyes, nose, mouth, and hair, whatever it is. So it defines an image structure, okay, allowing the machine to recognize objects. Basically, it is see in simple words, spatial features is nothing but relationship between all of these things. So it will use a lot of libraries. No, no. See, we have to be very thankful for Guido Van Rossum for building Python and all the developers, all the researchers who have been working uh, so many years in this AI field. What they have done, they have built the entire architecture and they have kept it into one particular library. Yes, and that's it. We just call the library, install it, install the modules, just run it, 2 3 lines of code, khatam ho gaya. Is there any AI anywhere that has been tuned for medical purposes that is accessible to us? Um, yes, we need to check. Let me get back to you. There are actually you can search once again. You guys can build deep learning models for medical AI in healthcare. There is so much data set, so many diseases, blood cells, cancer cells, kidney diseases. You will find so many data sets available online. Download them. Okay, run the project and check. You will understand how AI is detecting the diseases. Okay, now chalo, let's get into the next one, which is as the next one. We have learned about ANN, CNN. You did it for the hackathon. Great. Hope you got selected. Yeah. Next one, RNN. Yes. So this is nothing but talking about how everything feels very human. So up to now we spoke about deep learning CNNs. Now we will talk about how the machine can respond to us in our conversation. Okay. See, conversations, whatever we are having in our regular lives, okay, those are all sequences. Okay. Language itself is a sequence. What is a sequence? One after the other, right? Everything. Our life is a sequence, conversations are sequence, music is a sequence, language itself is a sequence, and that is exactly where this RNN. Okay. Take input and maintaining sequence. Yeah, there are so many students who don't have the basic knowledge of ML and DL also. Let me do this. Okay. So think about how you understand sentence. I say yesterday, okay, guys, tell me the next word I'll be telling now. What might be the next word? Okay, here is the statement. Yesterday, because it was raining heavily, I decided to. Can you complete the statement? Because it was raining, I have decided to stay at home, not to go to college. I decided to stay at home. Yeah, yes, good. You're already predicting what might come. See, what you're doing, you're already holding earlier words in your mind while processing the new ones. If you forget the first half of the sentence, the second half would make no sense, right? RNNs are designed to do exactly this. They don't treat data as isolated points, they treat data as a flow where the past influences the present. Okay. So here is something important to understand. RNNs were one of the first steps towards AI that feels conversational. Now you're going to study agentic AI, but the beginning, the birth of this agentic AI started with RNN itself. Okay, please respect this RNN a lot. Okay, so before this, AI could only answer fixed questions. After this, AI could hold a conversation, a complete conversation. But even then, this RNNs were also having a lot of limitations. They could remember short-term context, but long conversations were difficult. Still, this was a huge breakthrough. You know, it allowed AI to stop reacting blindly and started responding thoroughly. Not predict. Prediction was already done by ML itself. Oh my god, I got good responses. Not to go to college, take an umbrella. That means NLP is also part of it. Yeah, of course, NLP is of course part of it. Decided to dance. Okay. This is now. Oh my god, Indrajit, that's a really good point that you took out. Yes, that really works the same way. Yeah, it understands all the words, right? Correct. Good point. One example, ChatGPT dear. So, why does this matter in agentic AI? I told you, right? Because an agent, what? Okay, tell me one word. What is making this RNN work or predict the new data? New word? No, Samad, you cannot see others' messages. I know it is kind of boring, right? When you don't see other messages. I'm actually enjoying it. Yeah, sequence data. How do you remember the sequence? The major concept here is memory, guys. If the machine is not having the memory, it cannot predict the next word. Do you understand? Because an agent without memory is useless. Imagine a human employee who forgets everything. Imagine a student who forgets everything. No, right? You would never trust them with any responsibility, right? Memory is what allows learning. Memory is what allows improvement. Okay, RNNs were a major step in teaching machines how to remember and learn from sequences rather than some isolated events. Yes, Pratik. Good. So whenever you think of RNNs, don't think of them as just another neural network, guys. Think of them as a moment AI started remembering. Okay, not just calculating. Yes, patterns. Yeah, of course, patterns. See how it is remembering here. Uh, there are a couple of words which always come together. Is a, okay, and it also identifies the importance of the words sequences. Yes, it learns the patterns, past patterns. So based on past patterns only, right, it is able to talk exactly the way we are talking. Got it? Clear all the three? Can I get a quick uh, cheers from all of you if you have understood all the three? Got it? Okay. Now there is a small activity. Okay. All of you must do it. Okay. Let me take a moment and tell you. Okay. I'll be sharing you one link. Okay. In the chat. Okay. I want you to get into that link and register yourself with the same email ID that you have registered for this course. Do you understand? Will you do that for me? Just 2 minutes task, guys. Okay. Can I get a quick thumbs up? Okay. Chalo. Yeah, this is the tab. Thank you. No, it's not a promotional content. It's a self-learning course that will help you from Future Skills Prime. Okay. So Future Skills Prime is one of the platform where you can learn multiple courses. So we would like you to please register into this. I have shared the link. There is no promotion here. We want you to register for this course. I have shared it, guys. Please check. Yeah, if it is from the orientation, if you have finished this task from the orientation, please ignore. People who haven't done this, please do it. Register into this platform. Already registered. This is from NASCOM, guys. We are officially partners with NASCOM. Done? Great. If you haven't if you have not done it, please get into it. Mentors, please share the YouTube video and the link in the Telegram group. Students will do that. Okay. Yeah, you can check the reference video. Thank you. Chalo, let's get into the agents again. The link will directly take you to the course. Okay. Yeah, Telegram group link also will be shared. Okay. Yes, it is mandatory to register. Yes, Srikar, that is the course. Okay, if it is done, shall we begin? Done, done, done. That's it. Quick thumbs up, all of you, so that I'll begin. Shall. So now, let's move into the heart of this session. Okay, the key characteristics. Okay, okay. So guys, we have seen what an agent. Yeah, Prashant, please try to finish that particular course whenever you are free. Okay. Chalo. Okay. Okay. How many of you agree that AI is smart enough? We all agree that AI is smart enough, right? Yes. Of course, it is smarter than all of us. But do you think it is powerful? See, an AI agent, when we talk about AI agents, we are not talking about intelligence only. We talk about the behavior. Yes, already take a lot of jobs, yeah, of course. Power as in responsible for the actions, deciding, taking its own decisions, and moving. Yeah. So an AI agent is not impressive because it knows a lot. Google knows everything. Yes, Google already knows a lot. Wikipedia knows a lot. An AI agent is impressive because it does something with that knowledge. It does something. An action is performed. It operates on its own, right? It pursues a couple of goals. It interacts continuously. With whom? With the environment, right? It reasons, it adapts, and most importantly, it persists over time. Okay, see, let's compare a normal AI system. You already know when you open ChatGPT, it waits. It does nothing until you type something. Later, it answers. Once you give your prompt, it will answer and then it stops. This is not an agent. That is a it waits until you give something and then it responds. That's it. Given, taken. That's it. But an AI agent does not wait. An agent watches, it monitors, it anticipates. Okay. See, imagine an AI system inside a company's IT department, guys. Okay. It doesn't wait for someone to complain about server clash. What it does, it monitors continuously. All the logs are monitored. It notices the unusual behavior. Okay. It predicts a failure before it happens. It takes action. Maybe it restarts a service. Maybe it might alert all the engineers. Okay. This is autonomous operation. Yes. Okay. Do you understand? It is autonomous operation, automatically doing the things without needing to be informed by the owner. Okay. Now think of this. Think about goal driven behavior. What do you mean by goal driven behavior? Uh, I would definitely say okay if you take notes quickly. If you have the habit of taking notes, please do it. That is what the sessions are for. So I was talking about goal-driven behavior. You don't need to tell the agent every step. You don't micromanage it. You give it a goal, keep the systems running smoothly. That's it. The agent figures how to do it. It checks the progress. If one action doesn't work, it tries another. This is very similar to how humans work when given some responsibility. Yes, this is what goal-driven means. Now, continuous interaction with the environment means the agent is always connected to what is happening. It doesn't operate in isolation, guys. It reacts to changes, updates, it updates what it is understanding, and it also adjusts to behavior, right? It is continuously interacting with the environment. This is why agentic AI feels dynamic. Do you know the difference between dynamic and static? Yes. Hmm. Good. Agentic AI is dynamic. It is having the ability to reason and decide what separates agents from automation scripts. Okay. See, if you give a machine script, it blindly follows. Okay. But an agent evaluates the situation. It chooses between options. You can see so many options, but it can identify. And as time passes, over time, it learns which decisions lead to better outcomes. Correct. Uh-huh. Okay, let me come back to the questions later. Let me finish this. Okay. Now, the last, persistence. Persistence is over time is the final and most powerful characteristic here. An agent remembers. It remembers what worked. It remembers what failed. It carries this knowledge forward. I wish all humans do this. Do you agree with me? Okay. We all remember. We also have to learn from mistakes and then grow. We also should learn from success. We also should learn from failure. And next time when you take any step, you make sure you do the good thing so that you get the success. Right? Thank you. Evening motivation, guys. Yeah. So it carries the knowledge forward. Okay. This is why agentic AI focuses on behavior, not just intelligence. Intelligence without behavior is useless. Behavior is where impact happens. Chalo, got it? All characteristics noted. Can I get peace emoji? Sorry, victory emoji. Two fingers raised. I want to see the entire screen filled. No, no, everybody do it. I hope everybody are in the session being active. Done, done, done. That's how we need to live. Lots of peace. The end goal is peace, guys. Remember, okay? Wherever you are, whatever you are doing with, whoever you are with, make sure you're having the peace, satisfaction in your lives. Okay, now let's understand the, yeah, we already discussed this one, autonomy, goal behavior, adaptability, and persistence. Now, let's understand the core components of an AI agent. Okay, the core components. What do you mean by all of these components? As an agent is working, there are a couple of things it has to follow. Basically, a flow, a path. Okay, now let's understand each one of them in detail. Okay, what is the first thing here? What is it? मैम पीस की दिक्कत है. No one is ready to be peaceful for real. They all want to have generally fun over long-term peace. People need to realize, inner realization should happen. Yeah. Okay, let's get into perception. Yeah. This is where everything begins, guys. Perception is the agent's window to the world. Without perception, an agent is completely disconnected from reality. Without perception, if you're not able to think, can you understand how this world is working? Think about how you start your day. You wake up, you check your phone, you see messages, you notice the weather, you hear sounds around you. All of this information helps you decide what to do. If it's raining, you take umbrella. If you see an urgent message, you respond quickly. Your actions are driven by what you perceive. Do you understand? An AI agent works the same way. It constantly collects data from its environment. This data could be user requests coming through a website. It could be logs generated by servers. It could be sensor data for machines. It could be anything. Every one of these is a signal to the agent. Yeah, perception. Yeah, it takes the input from so many of this. It can take input from the environment, correct? See, inputs can be user requests, sensors, APIs, database from anywhere. Anywhere it can take the inputs in any form. No, perception is not agent's memory. Uh, See, memory is different here again. Agent's perception is that agent perception changes according to the environment. See, you stay in your college, your surroundings are different, your perception is different there. When you are at home, your perception is different. Similarly, agent also keeps changing its perception based on the environment. Okay, see, example, AI agent in working in a customer support. What it does, it reads incoming support tickets, it notices couple of keywords, it detects the urgency also. Okay, it sees patterns like repeated complaints from the same user or multiple users reporting the same issue. Okay, all of this happens before any action is taken. The agent is simply observing and understanding. See, perception is not just about collecting data, guys. Don't get me wrong here. Okay, so perception is not just about collecting data, it is about filtering. The agent must decide what matters and what doesn't. Okay, just like you ignore background noise and focus on a conversation, the agent learns to focus on signals that are relevant to its goals. Very important to understand that the perception is continuous. Yes or no? Is perception continuous? It does not stop once. It keeps listening, it keeps watching, it keeps sensing. All your mobile phones right now are listening to you. All your mobile phone cameras are watching you. Yes? Are they watching you? Be careful. This consent, the consent awareness allows it to respond quickly when something changes. Yes. Okay. So finally, without strong perception, everything else fails. The agent may reason incorrectly. It may plan poorly. It may act in a wrong way. Perception is the foundation on which the entire agent stands. That's the action. Showing an ad which we want to purchase is an action that is doing. That will be a different component. Okay. Now let's get into the next one. That is reasoning. Okay. Once an agent perceives something, okay, the next question is simple but very powerful. What does this mean? This is where reasoning comes in. Okay. Reasoning is the thinking process of the agent, continuously seeing the error messages. On their own, these messages are just text. But the agent reasons that the frequency of these errors is increasing. See, if you hear or if these continuous error messages are coming, what do you understand by it? The situation has some urgency, right? Yes, based on that, it will act. It remembers that similar patterns have occurred during a previous outage. Okay, it remembers, okay, previously when the frequency has increased in these messages, some outage took place, and that is why this time as it remembered that particular situation, now this time also the same thing is happening. Now what it has to do, it has to immediately check the entire system and make sure the outage is not happening again. Okay, listen, reasoning is not about one correct answer. It is about evaluating so many possibilities. Okay, the agent itself starts thinking. Okay, it might ask itself, is this a temporary thing or is it a known issue? Is this something new? What is the possible causes? Okay, what might be the reason? So, this will help an agent to reason. Do you understand what I'm saying? Another important aspect of this reasoning is understanding intent. When a user sends a message, the agent does not just read the word, it tries to understand what the user actually wants. The best friend, just like our best friend, okay? They know what exactly we want. Same thing, the agent also. Okay, is the user asking for information? Is the user frustrated? Is the issue urgent? This deeper understanding allows the agent to respond appropriately. Without reasoning, an agent would be nothing just but a script, just like this ChatGPT. Reasoning is what gives the agent the flexibility to think, to emotionally evaluate and analyze and give the output. And once an agent can reason, the next step, what it can be, it has understood the environment, it has started reasoning, started thinking about it. Now, what might be the next step? Guys, you need to understand these components really well because you will be given a situation, okay, and you will be asked which component of the agentic AI will it come under, and you should be able to answer which component. Are you there? Hello, hello. Thank you, thank you. Yeah, perception and what is the next thing we learned? Reasoning. Now, what might be the next step? Agent has learned it from its environment, collected so much of information. Next, exactly, Arjit. It's the planning. Okay. Planning. Every single day you plan. Do you plan? How many of you plan? I don't think so. You guys plan. Maybe sometimes consciously we plan, sometimes unconsciously. Okay. When you wake up in the morning, you already have an idea of what the day might look like. You may not write it down, but in your head, of course, it will be there, right? Today you are going to do this. Yes. What was your plan today? To attend college? No, today is Friday. It's a weekend. Tomorrow, day after tomorrow, it's a holiday, but we have session tomorrow. So see you all tomorrow again. I'm not ending the session, guys, but I will definitely connect with you again, okay? Tomorrow evening. Yeah. So what I was saying is, uh, planning is simply deciding the sequence of actions, right? Don't leave. No buys. No buy. Stay back. Yeah. Planning is what? Simply deciding the actions, sequence of actions. Do you agree? See, for an AI agent, planning works in a very similar way. Once the agent has perceived what is happening and reasoned about what it means, The next step, it asks itself, what should I do now? Yes, the agent thinks a few steps ahead, and you know what it does? It breaks the big, bigger goal into smaller, manageable actions. Okay, let's say the goal is to resolve a serious outage. Okay, the goal is too big to act on it directly. So the agent plans. First, it might decide what to identify the root cause. Then it might decide to check the system carefully. Then it might plan to restart the service or some fix the services. Then each step is chosen in a sequence, and each step will make sure it is making sense. What makes agent powerful? Can you tell me? Without proper planning, without prioritizing the task, things can't get solved, right? Not all actions are equally important, also. Some problems are urgent, some can wait. The agent learns to decide what needs attention first. Okay, this is critical in real world environments. Understood? So, planning is not about following a script, it is about dynamically choosing actions that move the agent closer to the goal. Okay. Without planning, an agent would react randomly. Without planning, with planning, it works very well. That's it. Now, planning is done. What is the next step? Yeah, it is creating script to deliver. Deliver is nothing but everything, whatever we have discussed till now, will lead to something called action. This is where the agent stops thinking and starts doing. Without action, perception, reasoning, and planning, all of these are useless. Okay, action is how the agent changes the world around it. Okay, so when an AI agent takes some action, it interacts with real systems, guys. It may send a mail, it might trigger a notification. For example, if you are only creating an agent, okay, to book the tickets on the first day we discussed, right? So to book a ticket, what is the action? It has to book the tickets. And how will you get a confirmation that it has booked the tickets? Hmm? You will receive a mail or you will receive a confirmation message, right? So that is the action there. Before doing that, it these are not simulations, these are real operations. You have given an access to an agent to do all of this stuff. Okay, so what makes this powerful is speed and consistency, guys. The agent does not hesitate, it does not forget, it it does not even get distracted. Once it decides an action, it executes this precisely, for sure. Okay. One more thing, some really important thing here. Okay. Action is observable. Can you blindly trust any agent? Just let me know. You have built your agent. Okay. You have asked it to book tickets. Okay. It has booked your tickets. But there will be some or other curiosity in our minds. Yes, how did this I mean, agent book the tickets? You want to know how it happened. You want to know the backend process, how it worked, right? Not blindly, of course, yes. So humans can see what the agent did. All the logs are updated. Okay, whatever messages it has sent, whatever API calls it has requested to make sure that particular goal is done, everything can be seen. This visibility allows trust. You guys are seeing not blindly. That's why we have this transparency. Okay. People can audit the agent's behavior and improve it over time. Okay. Action is the moment where AI stops being theoretical and starts delivering properly. Okay, clear? So we finished four things: perception, reasoning, planning, action. Okay, now let's talk about memory, because this is what connects everything together. Somebody were talking about memory, so this is where it comes. Okay, so memory is what allows an AI agent to grow over time instead of repeating the same mistakes again and again. See, imagine if you forget everything you learned yesterday. Every morning you would start from zero. Just imagine your lives like that. Just imagine. Every day you forget. Sayara movie. Yeah. Good one. Yeah. So the thing is, the same applies with agents, guys. No problem. So without memory, they cannot improve. They cannot, who are they? The agents here. They cannot maintain context. They cannot build any experience without the memory. So an AI agent's memory stores information from past interactions, guys. Okay. So it remembers what it perceived, what decisions it made, what actions it took, what results followed. This memory can be, of course, short term or sometimes long term. It's like it remembers the patterns anyway. Okay. For example, if an AI agent handled a system failure, maybe last month, okay, it remembers what caused it and how it was fixed. When a similar issue is appears again, the agent resolves it even faster. Okay, this is learning in action. Memory also enables continuity. Okay, do you understand? The most important thing to understand is that memory turns agents into long term problem solvers. Do you understand? See, once we keep doing the same task again and again, we become very good at it. Exactly the same way, agent also does. If it is the same environment, fixing the same problem multiple times, the speed of the agent increases. This is why memory is not just a feature, it is the foundation of the behavior. Okay, without memories, there is no growth, guys. Okay, with memory, AI agents become better every single day. Got it? So, yeah, so these are not steps. They form a continuous loop that runs all the time. Think about how you live your life. You observe everything. We have already discussed it. So, this loop is what makes agents fundamentally different from software, traditional software. Traditional softwares run when you click a button. Okay, your intervention is required there. But here, it is not required. For example, okay, we already discussed a lot. It's okay. So, in this loop, the thing you have to understand is this loops allow agents to improve without being reprogrammed every time. Humans don't need to write, we as developers or anything, we don't have to rewrite the agent for every new situation. The agent adapts by cycling through this loop again and again. This is also why agentic AI feels active, proactive. The agent doesn't wait for a command, it is already in the loop. When something changes, it responds immediately because it was already paying attention. Once you understand this loop, you stop thinking of AI as a tool. Okay, you are using ChatGPT, Gemini, and all, right? So you don't think that those are completely different from AI agents, right? You start seeing it as a system. Okay, how is the system working? It lives in an environment, it continuously interacts with it. Yes, that shift in mindset is crucial for all of you to understand the future of this AI. Got it? we will quickly jump into the types of agents. Okay, do not leave. Meanwhile, uh, mentors, please share the attendance link to the students. They'll fill the attendance. Dear students, I request you to stay in the session until the time. Okay. Meanwhile, you can fill the attendance. Thank you. Thank you for that. Okay, guys, we will start with the types of agents. Okay, shall we begin?
Recording has been resumed.
Can I get a quick thumbs up, maybe? Okay, chalo. So, types of AI agents. Okay, we have four different types again: reactive, deliberative, autonomous, multi-agent. Okay, let's start with the simplest type of AI agent. Okay, see, if you understand this, you will understand the other agents really well. Reactive agents are exactly what the name suggests. They react, nothing more, nothing less. They do not think about the past. They do not imagine the future also. They only look at what is happening right now and respond to it immediately. You all know the fire alarm, right? Huh? Think about this. When there is smoke, it rings. When there is no smoke, it stays silent. It does not remember yesterday's fire drill or anything. It does not plan for tomorrow. Okay, it simply reacts to the current situation. That is a reactive system. Reactive AI agents work the same way. Okay, a good example you already know is basic game. In this simple, okay, Mm, see, if you go to in a video game, maybe, okay. So if you go to the, oh, is my audio okay? Just a minute. Clear, audio is clear now. Can I get a quick confirmation? Yes, okay. So what I was telling in the video games you all play, if there is an enemy, okay, if you go near the enemy, immediately you will be attacked, or it will attack you, or you attack it. Rest of the time it stays silent lonely, right? So reactive agents are they are fast. Okay. That is their biggest strength. What is the biggest strength of reactive agents? They are fast. They are used in situations where speed matters more than intelligence. Okay. Do you understand? Can you come up with an example or a use case where reactive agents can work? I need to hear from all of you. Where attendance. Oh, what is this? Are you giving the use cases or the problems here? I am connected to a good network. Should not be an issue. Yeah, yeah. What I'm telling you is the fire alarm example I have given, right? So when there is a smoke, it automatically detects the smoke and immediately acts on it. When there is no smoke, it stays silent. So similar way, reactive agents are fast. So can you tell me some of the use cases where reactive agents are necessary? Oh, booking tickets online, automatic doors. Yes, correct. Anything else? Yeah. Okay. Email spam. Any other reactive agents? Sensor detection, motion door opens. Okay. Weather alert. How weather alert? Reactive. Automatic car. Chess game. Perfect. Chess game. And where the reaction is really fast. They are not learning anything. They're not learning anything. There is no memory. Only action. Okay. NPCs in video games. Vacuum cleaner. Okay, whenever there is a dust particle, it immediately goes and cleans it. Huh? Okay, okay, good ones. So these AI agents are fast, but they're limited also. They cannot learn, yes, they cannot improve, they cannot handle complex situations. They are like reflexes in the human body. They're only useful necessary whenever they're necessary, okay? But no longer, I mean, not intelligent as in a deep sense, they are not intelligent, okay? Clear? They don't have the previously stored data, but there will be some instructions given to it. Okay, so this is work on that. If this kind of question raises, immediately respond this way. Okay, attendance. Yeah, as soon as a face is detected, immediately take the attendance. Okay, done. This is the first type of agent. Now let's go to the second one, deliberative agents. So these are the thinkers. Okay. So unlike reactive agent, they don't just respond immediately or instantly. They pause, they analyze, they reason, they consider multiple possibilities before acting. Okay. See, how did you guys decide to choose this course out of all the other courses? You start thinking about the opportunities that might come after finishing this course? Hmm? What was the reason behind you choosing this course? Of course, interest of AI and the opportunities you will get, right? So, yeah, you are this is exactly what a deliberative agent does. Okay. A deliberative agent maintains an internal model of the world. It tries to understand how things are connected. When something happens, it reasons about why it happened and what might happen next. Based on that, it chooses action. For example, imagine an AI agent managing traffic signals in a city. Okay, a reactive agent would simply change lights based on sensors. Okay, a deliberative agent would analyze traffic patterns, time of the day, maybe past traffic data, and then decide how to control signals to reduce overall traffic. Is that system in your city? Is the slide changed? Not yet. Can you check again? Is the slide changed? No? God. But you're able to hear me? What happened to the slide then? Now? Are you able to see the slide? Still on. I have changed it to deliberative, guys. Okay, no problem. I think might be an issue from my side. But I hope you can hear me clearly. We will share the notes, don't worry. Don't worry about it. Okay, hope you're understanding. Okay, or else let me quickly. Okay. Can you see the slide now? Deliberative agents. Great. Okay. So these agents are slower than reactive agents. Okay. But they are much smarter than them. Okay. So they are used when decisions are complex and mistakes are maybe costly. Okay. They plan, they optimize, they strategize. So all of this comes under deliberative behavior. Okay. However, these deliberative agents still often depend on humans. Okay. Depend on humans to start the task or define exact situations. They think really well. Okay. But they don't act independently or instantly. Got it? We have learned two different types, reactive and then deliberative. Okay. Now let's get into the next one. Slide changed. Yes. Yeah. So autonomous agents. This is where AI stops being just a helper but starts behaving like an independent worker, as the name is saying, autonomous. Okay. It does not wait for constant instructions, it operates on its own. Okay. Without any defined boundaries. You give it a goal, you're not giving step by step process. Okay. The agent figures out how to achieve the goal directly. Okay. See, think about how a responsible CR, how many CRs here? You don't tell, I mean, responsible AI, sorry, responsible employee or a student, they are not told everything. They are given a goal, and by end of, I mean, by the deadline, they will finish it. You just say handle this project, they plan, execute, adjust, and report. This is autonomy. Okay. Autonomous AI agents work the same way. Naman, I understand you. Yeah. See, in an IT sector, autonomous agents does not wait for any human to report an issue. It keeps on monitoring the systems continuously. It detects problems. It tries solutions. It escalates only when needed. Okay, it remembers what worked before and improves over time. Okay, so autonomous, we have learned about the components, right? The perception, reasoning, planning, action, and memory. All of this, it keeps all of this into loop. Okay. They take the responsibility for all the outcomes. This is the type of agent that companies are more interested in today, because this is the type that can reduce the workload, increase efficiency, and operate everything at scale. But the autonomy also brings challenges. What might be the challenges? Can you guess? Quick. Prashant, where are you? Okay. Hmm. Wrong actions, errors. Where are your answers? I'm missing your answers. High costs ways to solve the problem. Okay. And control. Good point, Laksha. Control is one point. AI may accidentally delete important info. Yeah, security. Okay, trust and safety. There are three things I would like to cover up. Okay, trust, control, and safety. Okay, so that is why autonomous agents are usually deployed carefully, especially in enterprises. Okay. Okay, thank you, Prashant. Okay, now, yeah, so this is about autonomous agent. Now, let's understand the last one, which is this is something very powerful and very realistic. Multi-agent, sorry, it's not a single system. It's more like a team. Okay. See, in the real world, no big problem is solved by one person, right? Teams exist because different people handle different responsibilities. Multi-agent systems work exactly the same way. Instead of one AI doing everything, multiple agents collaborate. One agent might specialize in perception, constantly monitoring data. Okay. Another agent might focus on reasoning. Another agent might handle the actions and executions. They communicate with each other. They share the information. Okay. And they coordinate the decisions. Okay. So think about a company. HR, finance, IT, operations, all are separate units working together. Okay. A multi agent AI system. Just a second. What did I tell you? A company enterprise, right? So yeah, there is a HR team, finance team, IT team, operations team, everything. These are all separate units, but they're all working together. Multi agents also work the same way. For example, in this case, in a smart city, okay, one of the agent manages traffic, another manages maybe power usage, another monitors emergencies. So together they optimize the city's entire functioning. Not single agent has complete control, but together they create intelligent behavior and they make sure things are going well. Yes, this is where AI starts to look like an ecosystem rather than a tool. Okay, so I hope I am clear with all the different types. Okay, now let me quickly ask you guys. We have learned the different components, right? Can you type all of them? I did not ask you this question. Quick. What are the 5 components we learned? Perception, reasoning, planning, action, and memory. Can I get answers from everyone? Very good. Aditya, very good. Laksha, very good. Harshot, Arjit. Okay, now can you quickly type all the different agents? We have learned about reactive, deliberative, autonomous, and multi-agent. Here is the complete comparison of all the agents. You see, reactive, no memory, no planning. Autonomy is low and the complexity is also low. Hope you take a quick snapshot of this. Done? Okay. Now let's see how agentic AI is in. We have been discussing about this a lot. So again, a quick one. If you want to just go through the slide for a minute. Once done, please give a thumbs up. Okay, I'll continue the next last final topic of this day. I'll introduce you to IBM models. This will be included in the notes that will be shared, right? Of course, Joel, Shantan, Kumar, it will be there. Aditya, 15 more minutes. Can I get a quick thumbs up from everyone so that I can jump into? Okay. So, read this question. When AI starts acting inside companies, the big question is it is not can it do the work? The real question is can we trust it to do this work correctly? Yes, this is where IBM's approach to agentic AI becomes very important. IBM does not treat AI agents like experiments or toys. IBM treats them like some digital employees. Okay. In the real company, you cannot allow an employee to take random actions without any accountability, right? The same logic applies to AI agents. Okay. The IBM builds agentic AI with trust at the center. Okay. So I will tell you one thing. Okay. So the IBM's agentic AI approach. So as the course itself is telling you, okay. Um, so it has introduced a complete model for us. Okay. We call them as granite models, IBM granite models, which are used as generative AI LLMs. Okay. We can use them to build multiple generative AI models or agents in any way. Okay. These are granites are the granite models are pre-built pre-built models, meaning they have already built it and we can use them whenever we are working on any project. Coming to Watson X, it's a platform again. IBM Watson X platform, that's where you can build and deploy your projects. Do you understand? Yes, of course you will be working on the project. So, see, grenades, they belong to IBM's family of AI models. Okay, these are enterprise level models designed for all this reasoning, language understanding, task execution in the business environments. Okay, Watson X is what I told you. Watson X is the IBM's AI platform. Okay, it is used to build, deploy, and monitor the AI models and agents. Okay, and um so I think you can use it with your student ID for free, but we will let you know. Do not get into it immediately. I'll I'll guide you what to do, how to do, when to do it. Okay, clear? And I don't want to talk about this, but take a quick snapshot of this, the scope, the challenges. Please try to understand them. Done? Okay, just to summarize everything, what did we learn today? Can somebody give me a decent summary? Not in a professional way, maybe in your style. Mentors, I request you to please be ready with the quiz. Don't worry, Deepti will share you the notes again. Okay, the last 3 days notes will be shared again. Okay, thank you, Lakshya. We learned about types of neural network, components of AI, types of agent. Good. Others, what happened? You gave the attendance and you guys left? Huh? Good, Prashant. We started by learning different ways AI works. Then we learned how various AI agentic types reactive, deliberative, autonomous, and multi agents. Aditya, it's multi agents. Types of neural network. Okay. Good. Okay. Good, good, good. Yes, Abhyas, you need to fill the form regularly, and the attendance link will be only valid during the session, 6 to 8 only. Later, you cannot access the form. Okay, so I hope it is ready. Can I get the let me share my screen. Guys, please join the quiz. Please attempt the quiz and you guys can finish the session. Please join. Prashant being the first. Just to give an idea, we should try to finish the whole course when we can write all the tracks or some of them. Can you, Shrikar, can you please elaborate your question? Which course are you talking about? Yeah. If you have registered, please finish the course. Okay. It is, if you are interested in finishing it, please do it. Registering is mandatory. Okay. Okay, Prashant. Okay, let me begin the quiz. Make it 100 participants. Why people are not joining the quiz? No, no, no. It's not that way, Shrikar. Okay, chalo, begin. All the best. Thank you so much, everyone. I hope everybody attended the quiz. Thank you so much, guys. See you all tomorrow in the session. Bye bye. Have a great weekend. Sayonara. Bye bye. Thank you. No. There is no mandatory date. You can do it on your own, okay? Yeah, I remember Hyderabadi biryani. Come on Sunday, okay? I'll feed you. Bye bye.